Okay guys, so what we're going to be looking at in this tutorial is called the binomial expansion. We use the binomial expansion when we have a sum to the higher power to expand our brackets, because doing this the long way would take a lot of your page. So we have the binomial expansion to shorten our work here. The formula for the binomial expansion is in the log tables on the page 20. So if you look here, you can see that in your log tables you have the binomial expansion. We have the shorter version here, where we have the sum of n choose or x to the power of n minus or is equal to y or squared. Then we have the longer version here, where it's n choose 0, x to the power of n, etc. Okay, so this is on page 20 in your log tables. Now when we look at this, we know that x is going to be whatever the first term in our bracket is. So in this sum, for example, it's going to be 2x. Y is going to be whatever the second term in our bracket is, so it's going to be minus 3y. N is going to be our power. So to start off, we always have our power, which is 5, choose 0, by x, which in this case is 2x to the power of n, which is 5. Plus 5, choose 1, 2x to the power of 5 minus 1 in this one. My second term, which is minus 3y, which is secretly to the power of 1, which we just don't write. Because you see here, we're always minusing whichever number we have at the bottom of the choosing. Okay? So then we have 5, choose 2, 2 to the power of x by 5 minus 2, minus 3 to the power of y squared, because again our power is coming up. Okay? Now I'm going to move down here to continue the sum, so it's still the same sum, okay? Plus, so I had 5 choose 2, so now I'm on 5 choose 3, by 2x to the power of 5 take away 3, by minus 3x to the power of 3. Then I have plus 5 choose 4, 2x to the power of 5 minus 4, and minus 3x to the power of 4. Plus 5 choose 5, 2x to the power of 0, because 5 minus 5 is 0, so this one is actually just gone. Okay, so it's 5 choose 5 by 3y to the minus 3y to the power of 5. And now we're going to start simplifying on the next line. To put this 5 choose 0 into our calculator, we take our calculator in front, we press it on, we go 5, shift, and then above the divide sign you'll see the C for choose. So 5 choose 0 and then press equals, and I have 1. So 1 by 2x to the power of 5, which means I'm going to have 2 to the power of 5 gives me 32 x to the power of 5. Okay? Then we're going to keep going. So now we have 5 choose 1. So on our calculators again, 5 choose 1 gives me 5. 2x to the power of 5 minus 1 is 4. So that's really 2 to the power of 4. So we have 16x to the power of 4 by minus 3y. Plus we have 5 choose 2 again on our calculators. So we have 10 to the power by 2x to the power of 3. So 2 cubed is 8. So we have 8x cubed. This time it's minus 3y squared, which we know any minus squared gives me a plus, because a minus by minus is a plus. 3 squared is 9, so we have 9y squared. Plus, we're now on 5 choose 3, which gives me 10. So we can see we're starting to go back in a pattern. We had 1, then 5, then 10. Now we have 2x to the power of 5 minus 3, which is 2. So that's 2 squared, which is 4x squared, by minus 3y cubed. So minus by a minus by a minus is a minus. 3 by 3 by 3 is 27y cubed. And now I'm running out of room, so I'm going to go down here. Plus, we're now on 5 choose 4, which if you put in your calculators you'll see is 5, because we're going back in the pattern. 2x to the power of 1 is just 2x, minus 3y to the power of 4. So again, a minus by a minus by a minus by a minus is a plus. So we have 81, which is 3 to the power of 4, y to the power of 4. plus 5 choose 5 is just 1, minus 3 to the power of 5 is minus 2, 4, 3, y to the power of 5, say, which you can see there. So now we need to take our last line and we need to simplify it. So I have 1 by 32 to the power of 32x to the power of 5 just gives me 32x to the power of 5. In this one I have 5 by 16 by minus 3, which I'm going to put on my calculator, which gives me minus 240 x to the power of 4 and y. You should notice, guys, your coefficients should always add up to 5. So we have 4 and 1 here gives me 5. We have 10 by 80 by 9. So 10 by 80 by 8, by 9 gives me plus 720 x cubed y squared. So again, my powers add up to the original power, which was 5. Then we have 10 by 4 by minus 27. So again, we're going to have a minus this time. 10 by 4 by 27 gives me minus 1080 x squared y cubed. We're now down here where we have 5 by 2 by 81, which means we're going to have 810 x y to the power of 4. And my last one, we have 1 by minus 243, is just minus 243 y to the power of 5. And that's the full expansion with my final answer there. It is a lot of work, guys, but what you can see is there's little tricks as we go along. The most important thing is to remember that our formula is on our log tables on page 20 and that we need to keep going through it step by step. Where x in our formula is whatever our first term is, y in our formula is whatever our second term is, and n is always the power. Okay? Now, for example 2, what we're going to look at is when a problem becomes a bit more specific. So in example 2 here, if I just line it up, so you can see from example 2 here, it says find the coefficient. So the word coefficient means the number in front of a variable. So the number in front of a variable, and remember a variable in maths, guys, is just always talking about the letter. So we have the number in front of a variable. So it asked me to find the coefficient of the 5th term in this expansion. Now, if it's the 5th term, remember in our first term a second ago, we always had 5, 0, 5, 1, 5, 2, etc. So if it's going to be the 5th term and we start on 0, what my base is actually going to be is going to be 4. Okay? So in this example, we have 8 as our power. So we're going to have 8 choose 4 because it's going to be the 5th term. And when we start from 0, 0, 1, 2, 3, 4 is my 5th term. Okay? Then we are going to have our x and our y. So we're going to have 4x to the power of 8 minus 4 by 2y to the power of 4. So now we need to simplify. So again on our calculators, we're going to use our buttons. So 8 shift divide sign for choose and 4 equals, and I have 70. So we have 70 by 4x to the power of 4 by 2y to the power of 4. Okay, so 4 to the power of 4 on my calculator gives me 256 x to the power of 4, and 2 to the power of 4 gives me 16y to the power of 4. Now I multiply 70 by 256 by 16. So 70 by 256 by 16 gives me quite a large number. So we have 286,720 x to the power of 4, y to the power of 4, which means my coefficient, my number in front of the variables in this case, is going to be 286,720. So my coefficient is equal to 286,720. Okay? Now remember, guys, the whole way I was able to sub in and make this formula is from our log tables. We have the formula n or x to the power of n minus or, and y to the power of or. So again, that was on page 20 in our log tables. We have n is always our power, x is always the first term, y is always the second term. Or is the number in the series that we're on. So when we were looking for the fifth term, because we started 0, our or was going to be 4. Okay, if it was the sixth term, or would be 5, and so on and so forth. Okay, thanks guys.